I'm going to talk about our journey towards 5-axis laser-assisted selective metallization, working towards large 3D shapes. So I'll talk through our journey, not quite there at the end of it. Still at a low TRL, but just explain where we're getting to and where we're going. So Q5D is a startup company based just out of Bristol. We're a robotics and software company. Our aim is to automate wiring and additively manufactured electronics. So the basis of our technology is the machine that's now disappearing. Basically our process involves that machine and different end effectors. And different end effectors, which we can use to perform different processes. In the wiring side of the business, we deposit wire, glues, UV glues, we encapsulate, we can add connection all automatically. But I'm here to talk about the laser machine, which is built on the same platform. So the platform is a 3-axis XYZ gantry plus 2 rotary axes, a B and a C axis. And that gives you full 5-axis for 3D shape processing. It's quite a large build volume, so it's roughly around 1 meter cubed. And in this machine, we have a 100-watt fibre coupled laser. You can see there's also a galvo on it, which I'll come to in a second, which gives us some high-speed processing. Why the laser? That's because we wanted speed, accuracy, and we thought it could add value having a laser system. So what are the ingredients then for laser-based additively manufactured electronics? Well, you need a laser source, so we use a Trump 1064-watt light source. You also need a lens, a suitable lens to give you the resolution you want. High speed through the galvo fast-switching mirrors. You need a machine platform, which is our CY10. CAM and G code generation, a digital twin, which I'll come to, and spray. So we've done most of this, and we're kind of looking into the spray, which I'll come on to later. So our journey so far, we started about 2 years ago with the optical design, gantry-based ablation. It's quite important with rotational systems to align the light source so that you point in the right direction when you rotate the axes, because it's an integrated light source. Then we upgraded the hardware to a galvo. We've integrated software triggering. We have a digital twin, and now we're looking into different inks and spraying. So the hardware upgrade we had recently was using a galvo. That gives a bit of an advantage over traditional gantry-based systems because it involves using 2 very quick-moving, small mass mirrors. So essentially you get a very high speed to do a raster scan. So down here we did a quick test of about 50 by 50 millimeter piece in a few seconds, ablating away. It's just an painted aluminium business card in this case to represent a frequency selective shield, which we get a lot of inquiries about. So the idea is you'll do the slow movements with the gantry, but the fast movements with the galvo, and then you need to stitch and scan those segments together, which can be tricky on 3D shapes. So here's a bit of a video of the galvo. So you can see the speed there. And this is us. We painted some Dicatec silver paste just on a curved 3D substrate. That's the first pass, and then a cleanup pass. So this is all ablation, pulsed ablation. Then right at the end, you probably didn't see it there, there's a bit of sintering. So you create the image, if you like, from the blank substrate using ablation to carve the paste off. And then you use selective sintering, so we're switching to continuous wave because that's the thermal process rather than ablation, which you actually want to reduce the thermal aspect. So a bit more detail on that. So in the pulsed regime, it's good at ablation because essentially the electrons react to the photons much quicker than the lattice, so you can negate some of the thermal effects. It's even better with picosecond lasers. Ours is a nanosecond laser. But when you come to sintering, it's a slow thermal process. So you have to switch to a continuous mode laser, where you are implicitly trying to generate that thermal effect to evolve off the solvent and neck the particles at the right temperature. This can give you quite a narrow threshold, and you really